Welcome to Lesson 4 of Chapter 10, Advanced Swift with Bob the Developer. In Chapter 4, you've learned the practical aspects of protocol by learning about associate type and extension. However, we haven't really looked into how those native types, such as string and int, conforms to many other protocols that are predefined by the Swift engineers. Well, let's take a look at it today and let's begin. Welcome to Chapter 10. Let's learn about equatable and compatible protocol. So here's the problem statement. Understand that Swift is a protocol-oriented programming language. And then some of you guys be like, I've been using protocol for a while. Does that mean I know that Swift is a protocol-oriented programming language? Not really. You have to understand the fundamental type. So first of all, let's begin with a couple of examples. So if you take a look at it, what the 5 is an object of int value, right? And then the Bob is actually object of string value. But what's happening is you have this default operator. We talked about an operator before that comes along with this type. So how is this impossible? Okay, well, it's because they conform to int value and string value. They conform to a protocol called Equatable, and Equatable contains a method, a function called this one, equal sign. Well, if you don't believe me, let's take a look at it. Go to string value, go to click on it, and then type equatable. Okay, click on it, click. You'll see that string. It confirms that equatable protocol. Equatable protocol is something that already built by the Swift engineers, a protocol written by them. And then what it does is that it contains a static method, symbol operator, and then just left hand side, right hand side returns bool. So anything that confirms that equatable protocol, what it does is it has this symbol available. Okay, so if you create your own struct right now, just like normal struct, and call it random. You cannot do this. You're not allowed to do that because random. There's no such function for that because random does not conform to that protocol. Yeah, we can create our own protocol. However, it does not provide it. You have to conform to the equatable protocol in order to do that. Well, how to go about this? Well, it's pretty simple rather. So let's talk about equatable. So here we go, equatable. So if you want to conform to the equatable protocol, you have to have this method available. So what does the self refers to? We talked about it, the big letter self. The big letter self refers to the object, that class of blueprint that confirms that protocol. Okay, so let's create a custom struct called blog and author and title. Okay, and then what you want to do, you want to confirm that equatable protocol. So extension blog, all right, you can use extension for that. I'm going to use a lot in the next course and learn how to make your code more modular. Static function, if you take a look at it, just if you don't, go to jump definition and then just copy this thing right here. Just copy it right there, boom. You don't have to use public. We learned about access control right before. And then what we can do is the left hand side is going to be the blog and the right hand side of the blog. The custom operator, right? We talked about it before. And what you want to do here is you can provide your own custom implementation for that. So when you do this, you can always return true. Okay? You can always return true no matter what. But you want to definitely, because if you remember correctly about protocol is like a basketball coach. It tells you what to do. However, it does not. It's like a protocol coach. It tells you what to do. It does not know how to dunk a basketball. The implementation of itself, you can customize on your own if you wanted to. Okay. So, what are you complaining about? Expected. Oh, there must be something missing here. Yep, right there, something missing. The bracket was missing. Here we go. You can always return true. It doesn't really matter if it's Swift, if it's 1 to 3. It doesn't matter. It's gonna return true all the time. But you definitely want to provide some sort of better logic other than simply returning true. You want to do something like this. Return author equals right hand side author, and left hand side title equals right hand side title. So if the author matches and Swift matches, title matches, it'll only return true. Anything besides that, it's gonna return false. Okay, so what's happening is there's a protocol called Equatable, okay, and then it provides the full implementation. So why is this so important? Why is this, what's the matter about this? Well, here's the thing. Protocol allows you to, in fact, okay, let's go into the Swift documentation. So if you go to swiftdoc.org, this is kind of like a auto-generated documentation for Swift, and they have all kinds of stuff in it. They have types, they have protocols, they have operators available. You can just check them out if you wanted to. And here we're going to take a look at, there are a lot of protocols written by the Swift engineers, and today we're going to take a look at Equatable as well as Compatible out here. There are not many, right? There are like 40 or 30 of them compatible. Go click on Equatable right now. Go to swiftdoc.org. Doesn't really matter. Swift 3.1, 3.4. Go to Equatable. What it does is, and then go to View Protocol Hierarchy. Click here, and then kind of zoom in out, zoom out. So what's happening is, it's really funny. On the bottom here is actually the type written by the Swift engineers. So we can take a look at it. Int. There's a UI int 64. You have a float double. Okay. So what's happening is that Equatable protocol, all this type confirms that Equatable protocol. So for example, when you work with string value, it has that sign, that what do you call it, that equal sign, because it confirms the Equatable protocol. The bool has that. That's why you are able to do that. The int value has a float has that. Double has that. Int has that. All kinds of pretty much everything has that Equatable protocol and confirms that. So that's why what I mean by a protocol or in programming language, every single type that you work with in struct, not every single type, but if you work with string value, again, remember, string is nothing more than a struct value, right? Dictionary, they all confirm that Equatable, some sort of in some places, as is in string value, and then you can tell that, hey, this thing confirms that, so you should have that functionality of equal sign. Okay, that's what's happening. That's what I mean by Swift is a protocol oriented programming language. Every single data structure they're working with confirms that protocol, and then it kind of allows you to scale it. As long as it confirms that protocol, you have that feature. Okay, if it doesn't, you don't have that feature. But if you want to make your own struct has that feature, well, all you have to do is confirms that Equatable protocol, as well as provide its default implementation. That's it. Okay, cool. Now let's do some more interesting stuff, more useful stuff. So we can also create our custom create tuple, and then let's make it a little more exciting. So let's create a struct called grid point, and then we have var grid. And on the int on the left side, int on the right side, you're gonna initialize with number 1, number 2. You get the point, right? And so you can make a grid point like that. You can enter value 1, 2, but right now it doesn't work out, right? Because it doesn't work. This operator does not exist because, as you know, struct does not confirm that Equatable protocol. We want to have that. I mean, we could provide our own custom Equatable. We can provide our own thing, but you don't want to do that. You just definitely why not just confirms that Equatable, and then just better way to go about. Just make things you don't have to think that much. Just confirms that Equatable, and then you know what to implement. So here we go. We have extension grid point confirms the Equatable, and then we have a static method on the left side. Grid point, on the right side returns a bool. So what's happening is the same thing. The left hand side has matched the right hand side, left hand side. You get the point, right? So now you can do point 1 and point 2. You're able to compare both of them just like that, because it confirms that Equatable protocol. Okay, cool. It's false because they're not the same, but if you make it the same, just like that, it's going to be true right now. Okay, all good. So you learn about Equatable. Again, you don't need to memorize anything, all right? Just go to documentation, take a look at what things confirms that protocol, or if you want to learn about other protocols, then just go to this doc here, learn about what are some protocol, what are some requirements, and what feature can you do about with that. And today we'll take a look at comparable again, this part. So Equatable has that, if anything that confirms Equatable has that equal sign here. So comparable is something with, if you notice or not, something with, for example, like this. So comparable, you can do something like 10 is greater than 5, 10 is less than, you have that default implementation with that. It's because double and int, they all confirms that comparable protocol. Well, if you don't believe me, let's take a look at it. Go to here, go to comparable protocol, and then go to, you should go to the hierarchy here, view protocol hierarchy, and then let's type int right there. It should be on the top. You should have a comparable. Oh, it's interesting. If it's comparable, that means it also has to confirm the equatable. So if you remember correctly with protocol inheritance, you can have inheritance in protocol. So that means comparable also confirms the equatable. So when you have compatible, when something confirms the comparable, it not only has equatable equal sign, you also has to implement some of the features. And yeah, you can tell that int value, let's say if there's string value here. Oh, string also has a comparable. You can compare string value, so that's interesting as well. Yeah, that's what I mean by the comparable right there. So what are some requirements that you need to go? Well, just go here, comparable. Click on it. No need to memorize anything. Click on it, and then interesting. It confirms the equatable. That means anything that confirms a comparable, you have to have the equal sign as well. And there are 4 required methods that you need to implement. If you see static function, this one, and then this one. That's the requirement you have to have. And well, we're gonna provide that. So all I'm gonna do is copy and paste the requirement. Nice and simple, right? That's all you need to do. Copy and paste it, and then just follow the rule. And one of the example we can do is, well, I think you get the point, right? You get the point of what we use. I'm just copy paste this. Let's say we have an enum of OS, with one is Android and iOS. So you want to do something like this. If it's iOS, Android, iOS dot should return true, and then if it is iOS, is OS dot Android. iOS is always better, right? So it should return false. And how to do that? Well, you can create our own. Right now it doesn't confirm that. So what you want to do is you want to let iOS confirms that compatible and provide all the default implementation with that. Okay. So right now we don't have that because it does not confirm that protocol. Well, let's take a look at how to do that. I'm just gonna copy and paste. I think you get the point. So I don't want to bore you guys all. You get the point. Swift is a protocol-oriented programming language, and there are a lot of protocols. And then when you confirms that protocol, you have that provide the implementation, and as long as you provide the implementation, you're good to go. So here we go. If it's equal, yeah. I mean, I'm not gonna explain to you. This should be very easy. If you're confused about this, just read through it. But you get the point, right? As long as you yeah. So why is it protocol important? Well, if you think about it, it does not Swift is actually very flat. If you think about this, I mean. There's a little bit of what do you call that, nasty thing going on, because I mean protocol, they do provide inheritance, so there's a little bit of nesting going on. But like these are startable, these are protocol, but look, pretty much everything is straightforward. Even if I, I'm never really touched it, or never really dissecting the Swift code before, like internally. But for me to understand this one, it's pretty easy, right? This thing confirms that, this thing confirms this. Okay, cool. There's a relationship with that. Oh, since you have a stritable, that means there's a functionality comes with a stritable. So now I can take a look at, okay, this pointer struct should have that method. This thing should have that method. So you can use that. Yeah, that's why protocol is amazing, because you just take a look at it. As long as it confirms that protocol, you know what kind of method it contains, and it's just a easier way for you to visualize, and also what kind of feature you want to use it down the road. That's why I love using protocol. That's why Swift is called protocol-oriented programming language. It's not just about using and implementing protocol. It's about the entire language, written and following the principles of protocol, created by the Apple engineers, such as comparable, equatable, and pretty much the other 30 protocols out there. Okay. Today we talked about equatable and comparable. In the next lesson, we're going to talk about what makes for in loop possible. We talked about sequence. Anything that confirms that sequence protocol, Swift engineers have designed that. Hey, this thing can have for in loop. Okay. So we'll take a look at what it is, and then if you have any questions, comment down below. I'll talk to you guys soon. So far in this lesson, we've taken a look at 2 popular protocols. equatable, as well as comparable. You've discovered that Swift native types such as string and int confirms those protocol and had that required method associated. Do you start to see how protocol provide architecture for codebase? After that, you've also learned how to create your own custom types that conforms to equatable and comparable. As a result, that type also contains those magical methods associated. In the next lesson, you will learn what makes a for loop possible by learning about sequence and iterator protocol. See you in the next lesson.